Okay, today's lesson is looking at scatter plots, particularly constructing them. So scatter plots are a way that we can present bivariate data. And what do we mean by bivariate? Is bivariate data is two data points or two data measures or variables for the same piece of data. So in other words, we could make a bivariate data of a person with their height and then another piece of data with their arm span. So that would be one person with two data sets that we can compare. And we can repeat that for a number of persons. So whereas using box plots or dot plots are a way to presenting one uni data or one variable, scatter plots are used to present two variables. So the example we're going to look at is, to summarize that, an effective way, scatter plots are an effective way to see a relationship in data is to display the information as a scatter plot. To show how two variables relate to each other by showing how closely the data points fit to a line. So it's trying to see, is there a pattern of these two variables to be able to see any relationship. So here we've got is a shoe, we're looking at shoe size compared to the mass of a person in kilograms. And we're going to present the following information onto a scatter plot. So first thing we need to look at with a scatter plot is we need to look at our axes. So when we were looking at a dot plot, there was only one set of axes to use, or one measure. When we're looking at a scatter plot, we're using two measures. And once we've done that, we've got equal distances between each point. So in other words, this one goes up in fives, 5, 10, 15, and so on from 60. And then across the x-axis, the one that goes across the bottom, they go up in ones. So if you find it difficult, to remember the x and y axis, is remember that x is across, and also y touch the sky. The other thing to note with these set of axes is that you've got breaks. All graphs should start at 0, but because there's no value less than 60 or 4, it would be a waste of space to leave it. So you can always put breaks in your scatter plots. So the first data point we got is the first person has a shoe size of 5 and their weight is 65 kilos. So what we can do is we can find that on our graph, and what we end up with is 5 on the x-axis and 65 on the y-axis. So then we move on to the next person, which is what this point represents, and that's 12 and 97. Then we can move on to the third point, which is 7 and 68, which fits in there. And slowly we build up all our points going along the table until you've completed all of the values from the table. So that's our scatter plot. What we need to do is start looking at any patterns we see within that. The big thing to notice about this graph is that there are no values in this area and there are no values in this area. So if we try and think what that means, what we end up with here is this is a small shoe size but large mass. Here we think about this area, that's a large shoe size and a small mass. So generally, looking at the graph, it looks like it goes up in this direction. As you increase the shoe, so does the mass increase. So a way of describing this pattern is to use something called the line of best fit. And the line of best fit can be drawn onto data that shows a correlation. Correlation is another way of saying a relationship. The stronger the correlation between the data, the easier it is to draw the line. The line can be drawn by eye and should have roughly the same number of data points either side. That is not a hard and fast rule. Sometimes it would appear that it makes more sense to have a lopsided line of best fit. In other words, there's some points, more points above than below, but it is, if it's done by the LA, it's done roughly as an estimate. Now we have computers that can calculate a line of best fit with much more accuracy, and they end up with answers where there are not the same number of points above and below the line. So a line of best fit in this grouping would go through the center like this, and a line of best fit for this grouping would go like this. Now, how it's calculated, if you're using a computer, is that the vertical distance between the line and the points should be the same above and below the line. So in other words, if I take all the distance of the points above, that should add up to the same below. And that's obviously something a computer can calculate very, very quickly. Likewise with this one, the red distance to the line should be the same as the black distance for that grouping. The other thing, a positive or negative correlation is characterized by the straight line. With a positive, the strength of the correlation depends on the spread of the points around the line. So in other words, here we have a strong positive. So first thing is our lines going upwards from left to right are positive. The ones going downwards from left to right are negative. So then the following one is more spread out. So we say it's moderately positive. And last one's much more spread out. We say it's weak positive. This one's obviously less spread out, so it's strongly negative. This one's moderately negative, and the last one is positive. Again, it's not a hard and fast rules. There's other ways to describe strong, moderate, weak. And also, it's very subjective if you've got nothing to compare it to. You could, in some scenarios, this moderately spread positive graph could be described as strong, or it could be described as weak when compared to another graph. So going back to our data from before, what we can do is put our line of best fit. So we put an eyeball, we get our ruler, and we try to find the middle. Generally at this point, we're only interested in making sure that we match the pattern. So you won't be able to, a negative correlation going this way would not fit our graph properly, only a positive one would. And that's it. Putting our scattered graph together, that's what we're expecting. Correct axes, points plotted correctly, and also a line of best fit. So this one is positive. The last thing we're going to do is looking at making a prediction using your line of best fit. So we're going to use the line of best fit to estimate the mass of a man who has shoe size of 10.5, and lastly, the shoe size of a man who is 69 kilos. So the key thing about this graph is that we can measure 10.5 in a shoe size. Now we don't have a point for 10.5, so this is really an estimate. But measuring off that graph, we can then measure off that point of the line to the y-intercept. Sorry, the y-axis. And the y-axis, if we read off the graph there, we can predict that if a man has a shoe size of 10.5, that he would be around 87 kilos. It's really important to use the language that we're clear, that we're not saying that based on this relationship, every person with shoe size of 10.5 will be 87 kilos. It'll be around that. It's a good estimate. And it's certainly a better estimate that we would have done without the graph. Now, it also works in the other way. You do have to be a little bit careful about that you get shoe sizes correct. So the key thing with the shoe size here is that not all values between 6 and 7 are possible. You're not going to get a shoe size of 6.25. So it's a little bit dangerous to go through and make the prediction that if someone's 69 kilos, that they get a shoe size of 6. We're lucky it ends up being exactly on that value. Generally with discrete values, you can't do that prediction. So what I'm saying is that if it was, say it was 75, so if a man wears 75, okay, this measures down, and this is 7.4, you can't get a shoe size of 7.4. But you could suggest that they buy in size 8. Now, what is the purpose of this? Well, obviously, especially at the moment, if you're doing a lot of online buying, it's a pretty straight, easy way to guess what someone's shoe size would be that they would buy. You could say to a customer, if they don't know their shoe size, you could say to them, well, go and weigh yourself. If your weights are between these values, this is your shoe size, and so on and so on. So here's another one you can have a go at yourself. So grab a piece of paper, preferably a gridded paper, or you can use lines if you need to. So the question is, the table below shows that the number of people who visited the museum over a 10-day period last summer with the daily sunshine totals. Plot the graph. So the axes have been done for you. So copy the axes, then have a go at plotting the graph. So pause the video now and then restart when you're ready for the answer. Okay, so hopefully you gave that a go and you've got your graph and your points all sorted. So the first one we can plot here. The next one, 0.5, goes there. And we start filling in our points. We should see a pattern starting to form. Okay, so now that you've got this part, you need to put in your line of best fit. So pause the video if you need to. Try and guess where to put the line of best fit. Okay, now that you've put your line of best fit in, it should be along there. Doesn't matter if it's not exact, that's fine. So comment on the correlation or the relationship, it's negative. As the number of hours of sunshine increase, the number of visitors decrease, which is obviously the more sunshine you have, the more reason for people to be outside. So for the next part, I want you to try and use your line for the estimate to work out the number of visitors if there's 4 hours of sunshine that day, and second of all, the hours of sunshine when there's 250 people visit. Now, be aware that your answers will be different from my answers because our line of best fits won't be exactly the same. So pause the video and estimate those values. Okay, now that you've got your numbers for part C, 4 hours of sunshine, we can read off that axis, which gives us 310 visitors. 250 visitors, we can read at 5.5 hours of sunshine. Okay, so hopefully that got you going with being able to set up scatter graphs. There are a couple of things that are slightly different from other subjects, particularly with geography and science with using scatter graphs. You just have to be a little bit adaptable between the subjects. There's slight different reasons why there are differences, but none of those are important as long as you remember them. So if you could go to your OneNote page, open up the lesson, and complete the worksheet that's there.